Now, our topic for today is resultants of two factors. Don't forget, in our previous video, we classified quantity into scalar quantity and vector quantity, and we stated the factors on which addition of factors depends on. We said it depends on the magnitude itself as well as the angle between the two factors, that is the direction. So today we are going to find how to find the resultant of two factors. When you have two factors on an object, or let's say we have two forces acting on an object, how are you going to find the resultant of that two factor? Like I said in our previous video, it depends on the magnitude of the forces as well as the angle between them, that is the direction. Let's start with when you have two vectors or two forces parallel and act in the same direction. Therefore, you have something like this. Let's say this is the object. One person is pulling it like this. Then, let's call it F1. If this is the F2, it means the two forces are acting in the same direction. In that case, the resultant of these two forces on this object will be addition of the two forces, that is, resultant is equal to F1 plus F2. But if the two forces act such that they are opposite to each other, so we have one like this, then the other one is acting in opposite direction, acting like this. For you to get the resultant, it means you are going to subtract the smaller one from the bigger one. Let's say this F2 is bigger than this. So our resultant is equal to F2 plus open bracket minus F1, because it means this is our direction. So this one is acting in opposite direction to come with minus. Therefore, resultants of the two factors will become F2 minus F1. That is case 2, parallel and act in opposite direction. But what of if the two forces are perpendicular to each other? In that case, you apply Pythagoras theorem. We have it like this. You have the body. This is the body. One force is acting like this. Then the other one is acting like this. So you make it in form of what? Right angle triangle. If this is F1, this is F2. You have two ways of forming it. You can just join it like this directly. Where this one will serve as our resultant. Or you can form it like this. Draw your line from here. So transfer this one to this side. It's still in form of right angle triangle. This is our resultant. Therefore, the resultant R squared is equal to this F2 is here. This is F1 is equal to F2 squared plus F1 squared. Therefore, the resultant of vector is equal to square root of F1 squared plus F2 squared. Now, what of if you have the two forces and they act at an angle which is not equal to 0 and it's not equal to 90? It may be angle between 0 to 90 or angle greater than 90. Let's take for instance, if you have angle 30, in that case you apply cosine rule. You apply cosine rule. Let's say we have one force like this, then the other one like this. You use it to form a parallelogram. Yes. It's now in form of parallelogram. Then this. Therefore, resultant of this vector is the diagonal. Like this. This is the resultant. Then how we now find it? You use cosine rule, which will give you R squared is equal to If this is F1, this is F2. We have F1 squared plus F2 squared plus 2F1 F2 cos theta, where the theta is the angle between the two forces. Where theta is the angle between the two forces. And that will now lead us to parallelogram law of vector, which says if two forces are represented both in magnitude and direction by the adjacent side of a parallelogram, the diagonal drawn from the point of intersection of the two forces represent the resultant both in magnitude and direction. Now, let's go to the real example under this. If you have, look at this, we have, I said find the resultants of two forces, 3 Newton and 4 Newton, if they are perpendicular and act in the same direction. If they are parallel and act in the same direction, if they are parallel and act in opposite direction, if they are perpendicular to each other, if they act at angle 60 to each other, if they act at angle 120 degrees to each other. Let's start from the first one. That is, if they are what? Parallel and act in the same direction. Therefore, the resultant vector will be 3 plus 4. So which is equal to 7 Newton. But if they are parallel but act in opposite direction, in that case you subtract the smaller one from the bigger one, which will give us the resultant in that case. That is for 1. For the second one, we have R is equal to 4 minus 3, which is equal to 1 Newton. 1 Newton. Now, what if they are perpendicular to each other? They are perpendicular to each other, we apply Pythagoras theorem. In that case, number 3, we have R squared is equal to 3 squared plus 4 squared, which is equal to 9 plus 16. So we have 25. Then R now is equal to square root of 25, which is equal to 5 Newton. Now, then number 4, act at angle 60 to each other. Angle 60 to each other. Then we apply cosine rule. Cosine rule. In that case, we have resultant square is equal to 3 square plus 4 square plus 2 open bracket 3 times 4 cos the angle between the two vectors, that is 60, cos 60. Therefore, we have R squared is equal to 9 plus 16 plus 3 times 4, 12. 12 times 2, 24 cos 60. And cos 60 is 1 over 2. So therefore we have 25 plus 24 multiplied by 0.5, which will give us 12. The answer is 25 plus 12. So our answer is equal to 37. 37, that is R squared. Then, to find the final answer, just say R now is equal to square root of 37. So whatever you get must be in Newton. Whatever you get must be in Newton. And then you get something like 6 points, I think it's 6.08 Newton. 6.08 Newton. Now, the last one, if the angle between them is 120 degrees, so you apply the same method, but you just change your angle. The angle now is 120. Don't forget, 120 is in second quadrant, which is negative. Therefore, we have, this one will become 120 degrees. So, now give you 25 plus 24 open bracket minus 0.5. So therefore, this one will give for 25 minus 12. Minus 12. So which will give us 13. Therefore, that is R squared. Ordinary R, that is the resultant for the square root of 13. So if you find the square root of 13, we are going to get 3.6. So the resultant will be 3.6, something close to this, Newton. So that is how to find resultants of two vectors. So the next topic will be what? Resultants of several forces.